answering this question over here. So they're asking me to determine the velocity as a function of time for a raindrop continually accumulating mass as it falls through a vapor-laden atmosphere. Now you must assume that the mass as a function of time can be described by this function, and to also show that the result is what you expect when k approaches 0. So initially for this problem, I'm going to use in second law of motion, F net equals ma, and we know that this whole, for the raindrop, the force is due to gravity because it's falling down. So we can rewrite this equation just to accommodate gravity. So from that, I just rewrote acceleration in terms of dv over dt. And now, from here to here, since both velocity and mass do depend on t, they change as time progresses. So d is actually going to be the derivative of v and m over dt because negative rmg. So as a result, in calculus, when you have two variables that are both dependent on dt, and you're deriving them and they are multiplied of each other, you can rewrite this as this over here. So from then on, what I did, I looked at the second part of the equation, and I realized that this is dm over dt, and I was told in the question that mass as a function of time is this equation. So I derived this equation over here, and once you derive that, you get dm over dt, and that is equal to k. So that means I can just plug in k over here, which is in the next step of the equation. Once that was done, I multiplied through by m, and so I got rid of the m and my g over here, and I had m under this term. Now, it's very hard to do this, to solve this differential equation by hand. So I plugged it into Mathematica, and this is the equation that I was given to. So this is the equation that's going to represent velocity as a function of time for a raindrop continually accumulating mass. Now, the second part of that question was to determine what happens when k goes to 0. So if k goes to 0, I'm not going to deal with this equation. I'm going to go back to my initial equation over here. So now, if k goes to 0, therefore this whole term goes to 0 because we know that dm of dt is k. So as you can see over here, this term goes to 0, and the velocity or the acceleration of the raindrop is just due to gravity, and this is what you expect. So the mass will cancel each other out, then you have dv over dt, and to solve for v in terms of t, you have velocity equals negative gt plus the v initial, and this is what we expect because, as we can see, the definition of acceleration, not definition, but how you can rewrite acceleration, is changing velocity over time, and it's exactly the same thing we have over here, which is changing velocity over time. The only difference is that we have a negative of g, and the negative just stands for the direction of the raindrop.